All right, so in this section, we're going to be talking about what the graphs of quadratic functions look like. So we're going to go over some properties that they all have and make sure we can identify those. So if we're given a graph, we can find all these different important pieces of it. And then we want to be able to write a quadratic equation in a certain way called vertex form so that we can easily graph quadratic equations or functions, and then be able to identify all those neat characteristics. Okay, so I apologize first of all because my paper's like curling. I don't know why it's doing that, but this is 3.3a, and this is analyzing graphs of quadratic functions, and we're going to just go ahead and skip down here to where it says properties of parabolas. Okay, so these are all the things that we need to know. Okay, first of all is we need to know if our parabola is going to be opening up or if our parabola is going to be opening down. And that is determined by the leading coefficient here. So whatever is on, let me see if I can get this to focus a little bit better. Is that a little bit better? Maybe. So our leading coefficient is whatever's in front of that x squared term. If we have a positive leading coefficient, then our parabola is going to open up. Okay, if our leading coefficient is negative or less than 0, right, then it's going to open down. So that's the first little bit that we can determine is if we have a parabola that's opening up, we know our leading coefficient is negative, or if it's down, we know it's positive. I said that backwards. If it's opening up, we have a leading coefficient that's positive, and if it's opening down, we have a leading coefficient that's negative, right? So if we're given a graph, we should be able to tell about the leading coefficient. If we're given the leading coefficient, that's a piece that we should know about the graph, okay? The next bit of information is something we've already done before, and that's identifying the intercepts. Now, we do want to know the x-intercepts and y-intercepts. Parabolas, depending on where they're located, if we have a parabola that looks something like this, it's not going to have x-intercepts, right? Because from here, it's already above the x-axis and it's going up. Same thing if I have a parabola that's down below the x-axis and going down, right? We're not going to have x-intercepts there. It's also possible just to have one x-intercept. So if we have a parabola that touches our x-axis, maybe in just one spot, then it's possible to just have one x-intercept, right? Or we could have up to two, because maybe we have a parabola that crosses at 2 points, right? So it's possible to have two x-intercepts. So it's really determined by our specific function, whether we have no intercepts, whether we have one intercept, or whether we have two intercepts, okay? The good thing about y-intercepts is we will always have one, no matter what, okay? No matter where this is located, eventually it's going to go out and hit the y-axis. So we should always have at least one y-intercept. And remember, the way that we solve for intercepts is we set the opposite variable equal to 0. So if we wanted to find the x-intercept, we would just set y equal to 0. Or if it's in function notation, we would set f of x equal to 0, right? And then solve. And if we wanted to find the y-intercept, then we would put 0 in for x and solve, right? So just a quick refresher on that. So x-intercepts is where the graph touches or crosses the x or y axis. So you can see down here, these are our x-intercepts, right? So if I wanted to write the x-intercepts of this, oops, not x-axis, the x-intercepts of this graph, this one crosses at -1, so we would write that as -1, 0, right? Because these are always points. And then it also crosses over here at 3. So we would write that as 3, 0, okay? And then our y-intercept is down here where it crosses the y-axis, and it crosses the y-axis at -3. So again, when we write our y-intercept, we would write that as the ordered pair 0, -3, because intercepts represent points on a parabola, so we want to make sure that we represent them as ordered pairs, okay? All right, so we know how to determine if it opens up or down. We know how to identify x and y intercepts. The next thing is the vertex. Now, the vertex point, I'm not really sure why, but someone somewhere decided that we're going to label that point HK. And what that vertex point represents is either that highest point on the parabola or the lowest point on the parabola. So you can see here, since this parabola opens upward, the vertex point is the lowest point on the parabola. Okay, or you can think of it as like the center of the parabola, right? So here our vertex point is the point, what? We're at 1 on the x-axis, and then we go down to -4. So this would be 1, -4 for this one, right? So if your parabola opens up, it's the lowest point. If your parabola opens down, then it will be the highest point. It's this highest peak or lowest valley of your parabola, okay? The next thing we need to be aware of is the axis of symmetry. Now, the axis of symmetry means that one side of the parabola looks exactly like the other side of parabola, right? And so the axis of symmetry is the line that cuts that parabola right down the center and makes one half look exactly like the other half. So you can see here I have it highlighted. The axis of symmetry is this line that cuts it right down the middle, right? Now, it's a vertical line. So when we write a vertical line, we can write vertical lines like that go through an x value, right? So we could write this as x equals whatever value that line goes through. So we can see here on our x-axis that goes through x equals 1. So that would be the line x equals 1. Now what's neat about this is the line that it cuts the parabola in half, because it has to be in the absolute center to cut it in half, it's always going to go through the x value of that vertex point, right? Notice here my vertex point was 1, -4, and it's x equals 1. So whatever the x value is of that center point, that's the x equals line that's going to cut this down the middle. So that's what this is saying up here. If we have a vertex point HK, then the vertical line x equals h is going to be the line that cuts it down the middle. Okay, so if we know our vertex point, we should also know our axis of symmetry, because it will always be x equals whatever that h value is of our vertex. Okay. And then the last thing that we look at is our maximum or minimum value. Now, depending on what your graph looks like, it's a max or a min. So if your parabola opens upward, we're looking for this low value. The lowest value would be a minimum, right? Now, if your parabola opens downward, right, then your vertex point is up here, which means that this is the highest point, right? So that would give you a maximum value. So when we're looking for a maximum or a minimum value, we're looking for that highest y value, if it happens to be up at the top of the parabola, right? Or the lowest value. So that value comes from our vertex also, right? The max or min value is always the number k, meaning the y value from your center point or your vertex point. So if we look at this one, our vertex point, the lowest point on here is at -4, right? So, and it's a minimum because it's at the bottom. So we would have a minimum value of 4. Oh, so, oops, -4. Make that a -4, right? So when we list our vertex point, our highest or lowest point on the graph, we automatically know from the x value or the h value of that vertex what our axis of symmetry is. And from the y value, we know what our maximum or minimum value is. Okay, so when I ask you for the axis of symmetry or the minimum, okay, on the worksheet that goes along with this section, make sure for the axis, because it is a line, that you don't just write 1. It needs to be x equals 1 because it represents a vertical line, okay? And when I ask for the maximum or minimum value, you need to identify if it's a max or a min, okay? And then just tell me what the y value is, okay? You don't have to say y equals because it's not a line. It's just a value, which is the lowest or highest value on that parabola, okay? All right, so I want y'all to practice this concept of identifying where the intercepts are, and then the vertex point, and then from the vertex point you should know the axis of symmetry and your max or min value. So on the next page here, there's 2 for y'all to try, and I have it all written out, so you just list the stuff, list the answers. Make sure your intercepts are written as ordered pairs and your vertex. Make sure your axis of symmetry is written like a line, and then be sure on your max or min value to circle either max or min so that you know if you know which one it is. Okay, so go ahead and pause the video and give those a whirl. And then whenever you're ready, unpause it and we'll go over it and see how you did. Okay? Okay, let's see how you did. So on the first one, you can see here the x-intercepts, right, are the ones that cross the x-axis, which is at -2 and 6. Make sure you write those as ordered pairs, not as one ordered pair. Don't write -2, 6, okay? Each one of these get their own ordered pair. So -2, 0, and 6, 0. And then our y intercept is where it crosses the y-axis, right, and it crosses up here at 12. So y-intercept is 0, 12. Our vertex point is that highest or lowest center point, right, which in this case happens to be 216. And so we can see that the line that cuts it right down the center, our axis of symmetry, is going to be x equals 2, with that highest maximum point being 16. Okay, so remember, both axis of symmetry and your min or max value come from your vertex. So once you know your vertex, you should be able to tell me these two things. Okay. All right. Number 2, again, x-intercepts. We can see it crosses at -2 and 4. Make sure you write those as their own ordered pairs, -2, 0, and 4, 0. And then our y-intercept is down here at -8. So we'd write that as 0, -8. Then we identify our vertex point, which in this point is down, or on this one is down at the valley of our parabola, right? Because this one opens up, and it's the point 1, -9. And I was just so stinky to just leave that on there for you, so you don't even have to think about it. It is already listed, right? But now that we have that vertex point, we can see that the line that splits it down the center is the vertical line x equals 1. And our minimum value, because it's down here at the bottom, at the smallest y value, is -9. Okay, so this is everything that we want to be able to identify when we're talking about parabolic functions or quadratic functions or graphs. Okay, so it's really easy once we have the picture to do it, but what we need to do is to be able to take a quadratic equation or a quadratic function, right, which is normally written, oops, get a pen that's different, which is normally written like this, right? This is kind of how we see quadratic functions written most of the time, is ax squared plus bx plus c, right? And we use a quadratic equation, right? Or the quadratic formula. So this is how we're used to seeing it. But how we want to write it is we want to write it in vertex form. Okay, vertex form makes our life so much easier, because if it's written in vertex form, we can easily identify what that vertex point is. So if we know the vertex point, then we can identify the axis of symmetry and if it's a max or min value, right? Okay, so here's what vertex form looks like. And this is how we want to write all of our quadratic functions or equations, okay? So notice here we still have an A, but instead of having a B and a C, we have it written in such a way that it incorporates H and K. Remember, H and K is our vertex point. So A is still our leading coefficient. So whatever our leading coefficient is here, notice we still have it written in front. So we can see by that A, if it's positive, our parabola opens up. If it's negative, it opens down. Right? Okay, and then the H and the K are our vertex. Now notice here, it looks like x minus h, right? X minus h. And over here, we have a positive h. So remember when we were doing all of our transformations and we were going through the HSRV process, whenever we subtract on the inside of a parabolic function, right, or any function, our x's are backwards from what we would think. So even though it looks like we're doing x minus h, that would move it to the right, and we'd end up at positive h, right? So just keep that in mind, that whatever your h looks like in this squared quantity, when you write your vertex point, it's going to have the opposite sign for the h value, right? Now notice the k, because it's outside the function, it looks exactly like what it does in the ordered pair. Okay, all right, so the question on everyone's mind is, what's the question on your mind right now? So the question is, how do we go from how our quadratic formula normally looks to how it looks in vertex form? How do we change it from looking like this to looking like this? And the answer is simple. We use completing the square. Okay, so the way that we use completing the square is first we're going to take this out of function notation, and then we're going to complete the square so that we end up with that squared quantity. Okay, and I'll show you that in just a minute. So once we have it written in vertex form, right, which we're going to use completing the square to do that, then we can easily identify the vertex, because all we have to do is look at our h value in here and our k value that's being added or subtracted outside the function. And then once we have it written like this, it's going to be really easy to solve for our intercepts and then be able to graph them and our vertex in order to get a nice parabola shape. So let me show you how to do that. Okay, so on the next page, here's an example. Now I want to use completing the square to rewrite each function in vertex form. So anytime they say we want something written in vertex form, that means that we want it written as f of x is equal to a times x minus h squared plus k. All right, so this is how we want it to end up looking. Right now, it just looks like a standard quadratic function, right? So here's how we use completing the square. The first thing we want to do is take it out of function notation. And I know we have a whole bunch of room here, so I'm going to write kind of like little notes for each step that I'm doing, okay? So I'm going to say take out of function notation. And the way that we take it out of function notation is, instead of writing f of x, I'm just going to write y. So we have y is equal to negative x squared minus 4x plus 5. Okay. Now the next thing we want to do is we want to make sure that our leading coefficient, that a value, in order to complete the square, we need it to be 1, just positive 1. We can't have numbers out there. We can't have fractions or decimals. We can't have negatives. So whatever's in front of this x squared, we need to get rid of it. Okay. So I'm going to go ahead and say make the leading coefficient 1, okay? Because completing the square only works, remember, if our leading coefficient is a 1. So right now our leading coefficient is a negative 1, right? It's kind of like we have a negative 1 there. Negative 1x squared minus 4x plus 5. So to get rid of that negative 1, I'm just going to divide it off. But if I divide it off of this term, I have to divide the whole thing by negative 1. So if I divide by negative 1 here, I have to also do it here, and even over here on the y, right? Because we want to maintain that equality. So now what it looks like is it looks like I have negative y is equal to positive x squared plus 4x minus 5. Now, I know it's been a while since we did completing the square, right? That was back in what? I don't know. We might have slept since then. 3.2a? 3.2b, I can't remember. Anyways, when we complete the square, we only want the two terms that have variables on them in order to complete the square. So whatever constant we have over here, we're just going to move it to the other side. Okay, so I'm going to say move constant to the other side. So I need to move this 5, and I'm going to move that 5 by adding. So I'm just going to write it here below. I'm going to add 5 to both sides. So now I have the negative y that was already there, and then the 5 that I moved over. So then on this side, I should only have x squared plus 4x, right? Okay, now this is looking more like something I can complete the square with. Now I don't care what's going on this side. I just want to use this to complete the square. So remember when we went over completing the square, pardon me, we take half the x term coefficient. So if I take half of 4, that gives me 2, right? And that's what we're going to square and add to both sides, right? Or that's what we can square and add to both sides and then use a shortcut. But either way, we need to square 2 and add it to both sides. Square and add. So I still have the negative y plus 5 plus, now I'm adding that 2 that I got from taking half the middle term squared. 2 squared. And that's going to be equal to my x squared plus 4x plus, again on this side, I'm going to add my 2 squared. I really should have written this outside the parentheses, because if it's a negative and we square it, right, it's going to make it positive. Okay, so now we can go ahead and simplify this left-hand side. So I have negative y plus 5 plus 4 is equal to, now I don't know if you remember the shortcut from when we were doing completing the square, but this side should factor into a perfect square quantity. And what it factors into is our variable plus the number we get whenever we took half the middle term. So when we took half of 4, we got 2. So this is going to factor into x plus 2 quantity squared. Now, if you don't believe me and you want to work it out the long way, you can go ahead and square this 2. So you'd have x squared plus 4x plus 4, and then you can do the sum product chart and work it all out, and it will factor into x plus 2 times x plus 2, which then you could write as x plus 2 squared. Okay. The reason that I'm having you do this shortcut going from this step to this step is whenever we get into nastier problems, sometimes we have decimals, sometimes we have fractions. And so if when we take half the middle term value, we get something ugly, we really don't want to have to do something, some product with something ugly. Okay, so let's remember this shortcut that it always factors into the variable plus whatever that half value was before we squared it, just the half value inside our squared quantity. Okay, so now before I go any further, remember the goal is to get it looking something like this. So I have my squared quantity now. Now I just need to get it resolved for y so that I can write it back as f of x. Okay, so let's go back down here. I've got my squared quantity, so I can combine my 5 and my 4. So this gives me negative y plus 9 is equal to x plus 2 quantity squared. And now I'm going to move my 9 over to the other side. I do that by subtracting. So I end up with negative y is equal to my squared quantity minus 9. And then the last thing I need to do to get this resolved for y is now to get rid of that negative, right? So just like we got rid of a negative before, we can divide by negative 1. But if I do it on this side, I got to do it to every term over here, right? So now that I have a positive y and I have a negative in front of my squared quantity, and then a negative divided by a negative makes this a positive constant term out here. So now I have it in vertex form. I am going to go ahead and write it back as a function since it was originally in function notation. So negative x plus 2 quantity squared plus 9. All right, so that was the first thing I needed to do, was to be able to write this in vertex form. So all we did was complete the square to get it into vertex form. And I'm just going to talk through it one more time just so that y'all can see it, so that when we do it the next time it makes a little bit of sense. So to complete the square, we're going to take it out of function notation. So it's written with a y. We're going to make sure our leading coefficient is a 1. So if there's anything in front of that x squared, we just divide it off. Okay, and then we want to isolate the x terms. So here I moved my 5 to the other side, and then I can do completing the square. So I take half the x term coefficient, square it, add it to both sides. On the side with my x's, I can use my shortcut to get my squared quantity. And on the left-hand side, I need to go ahead and work it out, okay? So make sure you do this step where you square it and add it to both sides. Even if you're going to use the shortcut over here, we have to make sure that that squared 2 ends up on the other side, okay? And then we just resolve it for y and put it back in function notation. All right, so now we have our vertex form. What we need to now identify is our vertex and find our intercepts, okay? So now that we have it written in vertex form, all we have to do is identify our vertex. So remember, from our shortcut, we can get our vertex point by looking at these two values. So here, our vertex, remember inside here we do x minus the h value. So if it's a plus, in order for it to be a plus, we would have had to have subtracted a negative, right? Or you can think about how x's are backwards. right? If it looks like a +2 inside the function, that actually moves us to the left. So moving us to the left puts us at -2. -2, 9. Okay. Now that we know what our vertex is, we should also know what that axis of symmetry is, right? So our axis of symmetry is going to be x equals whatever the x value is of our vertex, which in this case is a -2. And then we should know our max or our min value is going to be this 9. So let's think about it. Are we going to have a minimum value or a maximum value? We need to know which way it's opening. So all we have to do is look at this leading coefficient that's out here, right? Or you could even look at the original. If you see a negative leading coefficient, that means that our parabola opens down. So if our parabola opens down, our vertex point up here is going to create a maximum value, right? So now that we know we had a negative, which means our parabola opens down, which means our vertex point represents a maximum, now we can go ahead and go back down here and we know that we have a maximum value at 9. Okay, so let's go ahead and plot that vertex point. We'll draw in our axis of symmetry and make sure our max is at 9. So I'm going to scroll up here on our graph. If at any time I'm moving my paper up and down too much, you can always pause it to make sure you're seeing what I'm pointing out, okay? I don't think I can get this thing zoomed out far enough to show it all at once. No, it does not like me to try. Okay, all right, so let's go ahead and plot this point. So at -2, I'm going to be up at 9. -2, 9. Right? So from here, my vertex or my parabola should be opening down, right? I should get something going like this, right? But I don't know where it's going to hit my y-axis, and I don't know where it's going to hit my x-axis. So that's where the intercepts are going to come in. So let's go ahead and solve for the x and y intercepts. Now that I have it written in vertex form and I know my vertex, now we can solve for our intercepts. Okay. All right. So to find our x-intercept, we're going to let y equal 0. Now, we can do this two different ways. One, you can take the original function up here and set the f of x, because when I say y equal to 0, that's the same thing as f of x equals 0, right? So I could set this original one equal to 0, and I could try to solve by factoring or using the quadratic formula, if those are things that you are familiar with and feel comfortable with. I'm actually going to use my vertex form to solve for my intercept, okay? Because this would be really easy to get rid of by taking the square root. So I'm going to use this form to set y equal to 0. So I'm going to have 0 is equal to negative quantity squared plus 9. Okay? And then I'm just going to solve this to figure out what my x-intercept should be. So I'm going to take this whole squared quantity to the other side, because right now there's a negative in front of it. I could divide the negative off, but I'm just going to move it to the other side. So think about adding this quantity squared to both sides. So I'll end up with x plus 2 quantity squared, now positive, right, is equal to 9. And now that we have the thing that's squared completely isolated, we can just solve this by taking the square root of both sides. So if I take the square root of this side, my square and my square root will cancel, and I have to remember to do plus or minus. Anytime we solve by taking the square root, we have to put a plus or minus in there. Okay? So on this side, I'm left with x plus 2 is equal to plus or minus 3. And then I move my 2 to the other side by subtracting. So I have x is equal to negative 2 plus or minus 3. So I'm going to go ahead and work out what I would get for both of these. If I do negative 2 plus 3, that's going to leave me with a 1, right? So that's going to give me the x-intercept 1, 0. Okay? And then if I do negative 2 minus 3, that's going to give me negative 5. So that would be an x-intercept of negative 5, 0. So I'm going to go ahead and just move my picture back up so I can mark my intercepts. So I'm going to have one at positive 1, and I'm going to have one at negative 5. So now that I have 3 points on here, I could probably easily draw this, but I want to try to make it as accurate as possible. So I'm also going to find where it crosses my y-axis. It's got to be somewhere between 9 and 0, right? Because I got to go from this point down to this one. So it's got to cross in here somewhere. So let's figure out where that y-intercept is. Okay, so that was our x-intercept, right? For our x-intercept, we've set y equal to 0. So if I want to find my y-intercept, now I'm going to set x equal to 0. Okay, so again, let's think about which would be the easiest one to use. I could use my vertex form, and I could plug 0 in for x and square this all out and figure out what it equals. Or when I'm putting 0 in for x, it's actually a lot easier to use our original function, because look what happens. If we were to plug in 0 for our x's here, this term becomes 0, right? Because 0 squared is 0 with a negative sign is still 0. This term, I would get 0 times negative 4, still 0. And so really I'm just going to end up with 5, right? So I'm going to plug it into this original one because it's a lot easier to see. And I'm not going to be able to show you both, so I'm just going to write it down here. So I would get y is equal to negative 0 squared minus 4 times 0 plus 5. Okay, so I'm just writing the original function, but I'm putting a 0 in everywhere there was an x. Okay, so this term turns to 0. This term turns to 0, and I have a 5. So that means that my y-intercept is going to be the point 0, 5. Okay, so I have my x-intercepts that we found here. I have my y-intercept, which we found here. And so I'm going to go ahead and plot it. So we know it crosses at 5. And now we have a much more accurate looking parabola, right? So our parabola should look something like this. So we use completing the square to get it into vertex form. And then from our vertex form, we can find our vertex, which lets us know our axis of symmetry and our min or max value. So this is something we need to know, right? And then from there, we find our intercepts by setting 0, x equal to 0 to find our y-intercept, y equal to 0 to find our x-intercept. So when you work these, on your worksheet, this is how I want to see you do it, that you write out completing the square. Your vertex form is one of your answers. Then from that, find your vertex, your axis of symmetry, and your max min value, and then solve for your intercepts and write them as ordered pairs. Okay, so now that we've been through the whole shebang process once, let's see if we can do it again. Okay, all right, so let's look at the next page for another example. Oh, wish my pages weren't curling. Okay, so first thing we want to do is we want to write it in vertex form. So we want to be able to write this as f of x is equal to a times x minus h squared plus k. And the way that we go from standard form into vertex form is by completing the square. First thing I want to do is take it out of function notation. I don't want to write it with an f of x because that just gets confusing. So let's write this as y is equal to x squared plus 12x plus 32. Then remember, we want to make sure that our leading coefficient is a 1. So I look at what's in front of the x squared term, and here it already is a 1, right? If nothing's written there, it's an implied 1. So that's wonderful. Wonderful, right? Because that means we don't have to divide anything off. But when we complete the square, we really only need the x squared and the x term. So I'm going to move that 32 to the other side by subtracting. So I end up with y minus 32 is equal to x squared plus 12x. Okay, so now that I've got all my x terms isolated and my leading coefficient is 1, now I'm ready to complete the square. So I look at that x term coefficient and I'm going to take half of it. So I want to figure out what's half of 12. Half of 12 is going to be 6. So 6 is going to be the number that I square and add to both sides. Even if you plan to do the shortcut, make sure you square it and add it to both sides. So we have our y minus 32 on this side, and then we're also going to add in our 6 squared, okay? And on the other side, we have our x squared plus 12x, and we're going to add in our 6 squared to that side as well, right? So this side over here, we're going to do the shortcut with, because we should know what this whole mess becomes, right? Because when we do completing the square, we know that this side that has all the x's, that's going to turn into a perfect squared quantity. And what it factors into is our variable plus that half amount. So in this case, half amount was a positive 6. So we're going to end up with x plus 6 quantity squared, right? All right, so now that we have that, now we just need to simplify this other side. So I have y minus 32 plus, if I square 6, that gives me 36. So now I can combine these two numbers together, which gives me y plus 4 is equal to x plus 6 quantity squared, right? And then I want to go ahead and move my 4 to the other side by subtracting, because I want it resolved for y so that I end up with function notation, right? So if I subtract 4 over here, I end up with y is equal to the quantity x plus 6 squared minus 4. So now I have it resolved for y, but since they gave me the original in function notation, I want to go ahead and put it back in function notation. So we have f of x is equal to the quantity x plus 6 squared minus 4. This is our vertex form. Okay, vertex form. So we want to make sure we know our vertex form, because now that we have our vertex form, we can go ahead and identify our vertex. So we look at the number that's inside the squared quantity and the constant term outside the squared quantity. So we can see here that our vertex point should be the opposite of what's in here, right? Because a plus 6 makes us go to the left. So that's going to be negative 6, and then whatever the constant term is, negative 4. So now that we know our vertex, now we should also know our axis of symmetry and our max or min value. So our axis of symmetry is always x equals that h value of our vertex. So x equals negative 6. And then we need to identify if we have a maximum or a minimum value. So we need to know if our parabola opens up or if our parabola opens down. And remember, we determine that by the leading coefficient. So I can do that here because my leading coefficient, should always show up in front of my squared quantity. Or you can go back to the original. If I look at the leading coefficient here, okay, my leading coefficient is positive. So if it's positive, it's a positive 1, that means that my parabola opens upward. So that makes my vertex point down at the bottom of the parabola valley, right? Which means that I'm going to have a minimum. Okay, so now I can identify that I have a minimum value, and that minimum value is going to be the y value of my vertex, or the k value of my vertex, which in this case is negative 4. Okay, so now I've identified all this stuff that I need to know, and I'm going to go ahead and plot my vertex. So at negative 6, I'm down at negative 4. 1, 2, 3, 4. So we're right here, and so we're below the x-axis, and we know that it's going to open up, right? So if it's going to open up from here, I should have x-intercepts. So let's go ahead and figure out where it crosses the x-axis and the y-axis so we get a nice, pretty picture. Okay. All right, so now we're going to find our intercepts. So first we're going to go ahead and find our x-intercept. It usually it requires a little bit more work, right? And for our x-intercept, we're going to let y equal 0, okay? Or in other words, we're going to let f of x equal 0, since we have it written in function notation. So again, you can use the original function and set it equal to 0 and use factoring or quadratic formula, or you can use vertex form. I like using vertex form because I feel like it's the easiest, but you can use whatever method you like. So I'm going to go ahead and set this side equal to 0. So I have 0 is equal to my squared quantity minus 4. Now, unlike the last one, I don't have a negative in front of my squared quantity. So in order to isolate the squared quantity, I'm going to just go ahead and leave it on this side. And I'm going to move my 4 to the other side by adding. So I'm going to add 4 to both sides. So I end up with 4 is equal to my squared quantity. And now I want to get rid of that square on my squared quantity. So in order to get rid of it, I'm going to take the square root. When I do that, I have to remember plus or minus on the other side. So I get plus or minus the square root of 4 is equal to the square root of x plus 6 quantity squared. My square and my square root is going to cancel out, right? So I end up with plus or minus 2 is equal to x plus 6. And then I just need to move that 6 to the other side by subtracting. So I end up with negative 6 plus or minus 2 gives me my x values. So let's go ahead and figure out what those are. If I do negative 6 plus 2, that gives me a negative 4. Negative 4, 0, right? And if I do negative 6 minus 2, that gives me a negative 8. So negative 8, 0. We always want to make sure we write them as ordered pairs. Okay, so let's go ahead and put our intercepts up here on this graph. It's going to cross at negative 4, 1, 2, and negative 8. Okay. And that's already giving me 3 points that I can go ahead and make my parabola, but I am going to go ahead and find my y-intercept just in case it helps me draw a better picture. Because I don't know, is this going to open up and come across my y-axis right here? Is it going to shoot up super, super tall? So if I can get it on the picture, I will. If not, at least we have that so that we have that information. Okay? All right, so we found our x-intercept. Now let's go ahead and look at our y-intercept. So for our y-intercept, we're going to let x equal 0. And again, just like I said last time, you can use vertex form and plug a 0 in for x there, or you can use the original and plug a 0 in for x. I'm going to use this one because I know that when I plug 0 in for x into this original, any term that has x is going to go away. So that means that y is going to be equal to 0 squared plus 12 times 0, just putting zeros in where I see x's, plus 32. And when I put zeros in where I see x's, my first term just becomes 0, my second term just becomes 0, and then I have a plus 32, which means I get y equals 32. So my y-intercept is going to be 0, 32, and that's way too big to be graphing on this graph. So if you happen to get a y-intercept that's like way above our graph or way below our graph, don't worry about graphing it, okay? Just graph the stuff that falls on the graph, okay? All right, so I have it as graphed as I'm going to get it. I'm going to go ahead and just connect my dots. So we have something that looks like this. Notice I didn't draw it way out wide because I know this is not going to cross the y-axis until way up here at like 32, right? So make sure your graph kind of reflects how open or how wide or how closed that parabola should look, okay? All right, so completing the square to get it into vertex form, then identify your vertex, your axis of symmetry, and your max or min value, and then determine your intercepts for additional points, okay? All right, I'm going to do one more, and then I'm going to let y'all try some, all right? So let's look at one more. So first thing we want to do is get this thing in vertex form. Straighten my paper. So vertex form looks like f of x is equal to a times x minus h squared plus k, right? And we want it to look nice and pretty in vertex form, because then we can easily identify our vertex, our axis of symmetry, and our max or min value. So in order to get it into this form, we have to use completing the square. And we don't like to have it in function notation when we're completing the square. So let's go ahead and take that f of x out and write it with a y. So y is equal to 4x squared plus 16x plus 14. And then we have to make sure our leading coefficient is a 1, because completing the square does not work if your leading coefficient is anything other than 1. Must be 1 to complete square. Okay, so what I want to do is I just want to divide everything by 4. So I'm going to do y divided by 4. I'm going to do 4x squared divided by 4. I'm going to do 16x divided by 4. And I'm going to do 14 divided by 4. So when I do that, simplify a little bit, that's going to leave me with y over 4. I can't simplify that. Is equal to x squared plus 4x plus, now this one doesn't simplify nicely to a nice whole number, but I can reduce it, right? Both of these numbers are reducible by 2, so I could write this as 7/2. Okay. Now when I'm completing the square, remember I only need the x squared term and the x term. So I'm going to move that 7/2 to the other side by subtracting, because I don't need its help, right? So I still have my y over 4. Now I have a minus 7 over 2 is equal to x squared plus 4x. So now that I have my x squared and my 4x term isolated, now I can go ahead and do my completing the square. So I'm going to go ahead and look at that x term coefficient, and I'm going to take half of it. So half of 4 gives me 2. Right? So 2 is what I need to square and add to both sides. So on this side, I still have y over 4 minus 7/2 plus, I'm now adding in a 2 squared. On the other side, I have my x squared plus 4x, and I'm adding in my 2 squared over there. So on this side over here, the left-hand side, I'm going to have to do some simplifying, right? But on the right-hand side, I can go ahead and use my shortcut. My shortcut says that this entire side that contains these x variables is going to factor down into a perfect squared quantity. And we know it factors into our variable plus or minus, right? Whatever sign we get when we took half the middle term. This was a positive 4. So we took half of it, we get a positive 2. So that's going to factor into x plus 2. And then I just need to simplify the left-hand side, right? So over here, if I square 2, I'm going to get 4. So I would have y over 4 minus 7 over 2 plus 4. And I'm going to write that as 4 over 1 instead of just 4, because I'm going to have to combine these two things. And in order to do that, I need a common denominator, right? To combine negative 7/2 and positive 4 over 1, they need the same denominator, which is going to be a 2. So I'm going to have to multiply this guy on top and bottom by 2. That way, I get y over 4 minus 7/2 plus 8 over 2 equals my squared quantity. Okay, and now that they have the same denominator, now I can combine those together. So I get y over 4 plus 1/2, right? If I do negative 7 plus 8, that leaves me with 1/2 is equal to my squared quantity. Now I need to move my half to the other side, because now I need to resolve it for y. So I'm going to subtract a half. So I have y over 4 is equal to my squared quantity minus 1/2. And then the last thing I need to do to get y all by itself is get rid of this darn 4, right? And to get rid of that 4, right now it looks like y divided by 4. So to undo division, we're going to go ahead and multiply. So I'm going to multiply this term by 4 so that those will cancel. But if I multiply this term by 4, I also have to multiply the squared quantity by 4, and I have to multiply the negative 1/2 by 4. Okay, so what I end up with is the y right, which I can put back in function notation, times 4 times x plus 2 quantity squared. And then half of 4 is 2, right? And we have a negative, so this becomes negative 2. All right? And then we put it back in function notation. So f of x equals 4 times x plus 2 squared minus 2. And this is my vertex form. Okay. All right. And you can always double check yourself. Notice here we have a 4 out front, which is our leading coefficient. So you can double check. If you look back at your original, we had a leading coefficient of 4. So we did it correctly. Woo woo. Right? And remember, when our leading coefficient here is positive, that means that our parabola is opening upward, right? So we know our parabola is opening upward, which means we have a minimum value. So I'm going to go ahead, I'm just going to move my vertex form up here. Okay, vertex form we determined was f of x is equal to 4 times x plus 2 quantity squared minus 2. Make sure when you write your vertex form, you write f of x. Okay, if you only write that, it's not correct. That's not an equation. That's not a function, right? That's just an expression. Okay, you have to have the function notation and the equal sign for this to be function notation. Okay. All right, so there's our vertex form. So then from vertex form, we should be able to identify our vertex, right? So our vertex, if I look inside here, it's a plus. So we change the sign. So -2 and then a -2 constant on the outside. So our vertex is going to be -2, -2. And from here, it's opening up. So if it's opening up, it should go up and hit the x-axis, right? So now we need to figure out what our x-intercepts are. Oh, but before we do that, we want to list our axis of symmetry and our max or min value, which we know because we already did this, that it's a min. So our axis is always the h value, x equals the h value, so x equals -2, and our minimum value also happens to be -2, okay? All right, so the last thing that we need to find here is all of our intercepts. Okay, so I'm going to go ahead and list it here. Intercepts. So we have x-intercepts and we have y-intercepts. And I'm going to go ahead and work it out down below. So to find our x-intercept, we're going to let y equal 0. And I like to do this one with my vertex form, which is down here at the bottom of the page, or I have it written right here. So I'm just going to put 0 for the f of x side. So I have 0 is equal to 4 times my squared quantity minus 2. And now I need to solve for x. So I'm going to take my 2 and move it to the other side. It's subtracted, so when I move it, it becomes positive 2. Right? And then I still don't want to square root until I get the squared thing isolated. So I'm going to go ahead and divide off my 4 just to get rid of it. So I end up with 1/2, right? And let's see, I'm going to have to take the square root of that, aren't I? So I'm going to go ahead and write it as a decimal. I'm going to go ahead and just write it as 0.5 is equal to my squared quantity. And then to get rid of that square, I'm going to square root both sides. Don't forget your plus or minus on the other side. So plus or minus the square root of 1/2 is equal to the square root of x plus 2 quantity squared. So my square and my square root cancel. So I'm going to get plus or minus. Now the square root of 0.5 doesn't come out pretty. It's like 0.7071. Something like that, and it probably keeps going and going. I'm just going to write 4 decimals. And then here my square and my square root cancel. And the last thing I need to do to solve for x is move that 2 over. And since it's being added, I'm going to subtract it. So I get -2 plus or minus 0.7071 equals x. Now, this is obviously not going to come out pretty, right? It comes out to a decimal. So I would just keep at least 1 decimal place. My math lab may ask you for more, but on the worksheet, if you give me at least 1 decimal place, I'm fine with that because I don't feel like more than 1 decimal place is going to make you graph it any more accurately or less accurately, right? So I'm going to do negative 2 plus 0.7, and that's going to give me negative 1.29 and some more stuff, right? So I can go ahead and just say that that's approximately negative 1.30 as my first intercept, right? And then if I do negative 2 minus 0.7, blah, 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 then I get negative 2.70, blah, 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 right? Which I'm just going to say that's roughly negative 2.7. So negative 2.7 comma 0. So now I have my two x-intercepts. So I'm going to write them up here since I have all my other answers up here. Negative 1.30, negative 2.70. Okay. And then the last thing I need to do is find my y-intercept. So to find my y-intercept, I'm going to let x equal 0. And again, you could plug it into your vertex form in order to find your y-intercept. But when you're plugging 0 in for x, I find that it's a lot easier to do it on our original. So I'm going to end up with y is equal to, if I put a 0 everywhere I see an x, I'm going to get 4 times 0 squared plus 16 times 0 plus 14, right? And then the terms with the zeros all go to 0. So I end up with y is equal to 14. And then I want to make sure that I write that as an ordered pair, 0, 14. And then I'm going to go ahead and write it up here since this is where I have all my answers written. So for this problem, this is all the information that I needed to know. So make sure you have all this type of information when you do the practice problems, and make sure you have all that information highlighted, boxed in, circled, fluffed around, however you want to do it on the worksheet, okay? All right, so let's go ahead and graph our intercepts. So for x, we're saying negative 1 point a little bit. So negative 1 and a little bit would be right in there. And then negative 2.7 is almost to negative 3, right? And then our y-intercept is at 14. Now this is just a 10 by 10 graph. So if I wanted to graph 14, it would probably be like somewhere up here. So this is going to have to be really tall and skinny so that it doesn't cross until way up there, right? So I'm going to go ahead and just make it super tall and skinny. Something like that. Okay. So again, you do your best with your ugly intercepts. And if your y-intercept is off the graph, you don't have to plot it, but make sure that you make your parabola, you know, skinny enough or wide enough accordingly. Okay. All right, so hopefully I did not overkill here. Hopefully 3 examples is enough, but I want to make sure that you can do this on your own. So on the next several pages, I think there's, let's see, 1, 2, there's 2 for y'all to try. Okay, so I want you to go through the completing the square process to get it written in vertex form. Once you have vertex form, identify the vertex, the axis of symmetry, and your max or min value. Make sure you tell me if it's a maximum or a minimum. And then find your intercepts, okay? And then once you have done that, you can unpause the video and check yourself. See how you did, okay? There is a worksheet that goes with this section, so that will now also be due. Now, in the next part of this section, this is 3.3a, in the next part of this section, 3.3b, I'm going to teach you a shortcut. But I will be grading this worksheet on if you can go through this completing the square process. So make sure that you are doing it in the way in which it was intended to be done. And then once we learn the shortcut later on, you can always go back and check to make sure you did it correctly. Okay? All right, so pause the video. Let's see how you do. Okay, so let's go ahead and see how you did on the first one. We want to take it out of function notation, write it with a y, and then move our constant over to the other side. So you should have y plus 3 equals x squared minus 2x. Then from here, we take half the middle term, and that gives us our negative 1 that we're going to use for our shortcut, right? That's our shortcut number. Now, When you take half of that middle term, notice here it was a -2. So when you take half of -2, this is going to be a -1 that shows up inside our little shortcut squared quantity, okay? But before we do that, we're going to take that -1 and we're going to square it. We're going to add it to both sides. So on this side, we can go ahead and work that out. On the other side, we're going to use the shortcut. Our shortcut says that it factors into a perfect square quantity, and the number that's inside the squared quantity is going to be that shortcut number we got when we took half the middle term. Okay, so this factors into x minus 1 squared on that side. On the other side, I'm just going to simplify. So the -1 squared becomes +1. 3 and 1 gives me 4. And now that I'm at this step, now I need to get y solved. I need to get it solved for y. So I'm going to go ahead and subtract that 4 to the other side. So I have y is equal to my squared quantity minus 4. Okay. We can see here that our leading coefficient was a 1, which is positive. So we know our parabola opens upward, which gives us a minimum value. So now that we have it written in vertex form, right? All I have to do is replace my y with f of x. Now that we have our vertex form, we can look inside our squared quantity and at our constant term out here and see that our vertex is going to be 1, -4, which means that our axis of symmetry is x equals 1. Make sure you write x equals, not just 1. And our minimum value is -4. Then we just have to find our intercepts. When we plug 0 in for y, I use the vertex form to solve, and I got 3 and -1. Be sure you write them as ordered pairs. And when you put 0 in for x for your y-intercept, you should end up with -3. Again, make sure you write that as an ordered pair also. So this is all the information I'm looking for on your worksheet and on an exam, is that you're able to write it in vertex form using completing the square, that you can identify your vertex, your axis of symmetry, and your max or min value, and find your x and y intercepts algebraically, okay? Once you have all that information, you should be able to graph your parabola and get a decent picture. In this case, everything was on the graph and it worked out nicely. No decimals, pretty numbers, okay? Let's look at number 2 and see how you did on that one. If I'm going fast, you're welcome to slow down the video. YouTube lets us do that now. Or hit pause so that you have a little bit more time to look it over. Okay? All right, number 2. We start by completing the square. Actually, it's even fine if you want to start by identifying if you have a max or min. We can see here that our leading coefficient is a negative. So we know our parabola opens down, which means we're going to have a maximum. Okay? All right, so let's get it into vertex form. We take it out of function notation by using y instead of f of x. And then our leading coefficient must be 1 in order to complete the square. So we're going to divide the -2 off everything so that we get just a nice x squared. And in order to complete the square, remember we only need the x squared term and the x term. So we're going to take that constant term and move it to the other side by subtracting. So I have my y over -2 and my -5, and now I have my x terms all nice and isolated. So I'm going to go ahead and take half of that x term coefficient. So when I take half of -6, that gives me my shortcut number of -3. So -3 is what I'm going to square and add to both sides. -3 is also going to be the number that shows up inside my squared quantity. Okay? So when we square -3 and add it to both sides, the whole right-hand side, I can use the shortcut, and I know that's going to turn into x minus 3 squared. On the left-hand side, I have to go ahead and square out that -3 to get 9, and then combine it with the -5 that was already there, which gives me a +4. Okay? And now from here, I just need to resolve this for y. So I'm going to take that 4 and move it over by subtracting. And once I've moved my 4 over, then I need to get rid of this -2. I have a y divided by -2, so to get rid of that division, I need to multiply by -2. If I multiply this one by -2, I also have to multiply both of these terms by -2. So that puts a -2 in front of my squared quantity, and when I multiply the -4 by -2, I get a +8. So that gives me my vertex form. All I have to do is replace that y and write it with an f of x. So f of x is equal to -2 times my squared quantity plus 8. And looking at this, I should be able to identify my vertex now, right? Because inside here, I change the sign, which gives me a +3, and then I keep my constant term the same when I put my K value in here. So my vertex is 3, 8, which you can see I graphed above. We know that it's opening down, so we should have a maximum of 8. And then our axis of symmetry is always the line that goes through that X value of our vertex, right? Or our H value of our vertex. And then we just need to find our intercepts. So again, when we find our intercepts, the x-intercept we find by putting 0 in for y. The y-intercept we find by putting 0 in for x. I love to use the original function when we put 0 in for x because it's pretty easy to calculate. For the x-intercept, it's up to you. You can use vertex form, which is what I have shown here, or you can use the original and then use quadratic formula. Okay. Either way, you should have x-intercepts at 5 and 1. Be sure to write them as ordered pairs. And our y-intercept should be at -10. Make sure you write that as an ordered pair. Okay. So once we have all of our intercepts, we can plot those. In this case, we got lucky enough that they all landed on our graph. So we graph it, we should get a parabola that looks something like this. Okay. Be sure you identify all of these things on your worksheet. Okay. All right, so that is the end. You should now be able to do 3.3a and the 3.3a worksheet. And yep, I think that's all I have to say. Let me know if you have any problems, if you have questions, or you need help.